Hi guys, welcome to the lesson of ordinary differential equations. So in today's class, we are going to discuss about the exact differential equations. So previously, we talked about homogeneous and equations reducible to homogeneous differential equations. So now we are going to talk about exact differential equations and the working procedure and the concept and the identification of the exact differential equations, right? So let's say that if we have a differential equation of this form, m dx plus n dy is equals to 0, where m is equals to some function of x comma y, and is also equals to some function of x comma y, and the partial derivative of m with respect to y is equals to partial derivative of n with respect to x, then we call it exact equation, right? So this is the general idea of exact equations. Simply what we need to do, we need to uh, transform the equation to this form and check, identify m and n, and then check whether these partial derivatives are equal or not, right? So let's start with an example. So question number 1 says that we have 5x to the power 4 plus 3x squared y squared minus 2x y cube times dx plus 2x cube y minus 3x squared y squared minus 5 y power 4. So first of all, we need to check whether the equation is exact or not, right? So what we need to do, we need to identify m and n, so we can see that the function with dx is m and the function with dy is n. So m is equals to 5x to the power 4 plus 3x squared y squared minus 2x y cube, and then n is equals to 2x cube y minus 3x squared y squared minus 5y to the power 4. So differentiate partially this with respect to y. So this will be 0 because it's a function of x only, plus this will be 6x squared y minus, and this will be 6xy squared. And then for our n over our x, we have 6x squared y minus 6x y squared minus 0. So we can see here that dou m is over dou y is equals to dou n over dou x, which is further equals to 6x squared y minus 6xy squared. So this is enough to say that this equation is exact equation, right? Exact equation. So first step is now clear, that we just check that it's an exact equation. So what next? Now we need to solve this equation and we need to find the solution of this equation. So what we have to do is simply integrate the function that is with that is m 5x power 4 plus 3x squared y squared minus 2xy cubed times dx, right? And plus integral 2x cubed y minus 3x squared y squared minus 5y power 4 dy, right? But here we need to stop and we need to concentrate that what else we have to do here. Here simply y will be treated as a constant, right? Y will be treated at constant, and here any function of x, any function that involves x or function of x will be equals to 0, simply like this. Here x is involved, so this will be 0. Here x is involved, so this will be 0, right? Like that. So any function of x or any polynomial of x or something like that, like e to the power x, ln x, tan inverse x, any function of x is present here, then we will simply make it 0, right? Whatever, if it's doesn't matter if it is in within product of y or it's in the division, right? So y is constant here. Now I will integrate with respect to x, so it will be 5x to the power 5 over 5 plus 3x cubed y square over 3 minus 2x squared y cube over 2 plus, and then this is this we will integrate with respect to y, so is 5y to the power 5 over 5, and then equals to constant c, that is constant of integration. So the solution is x to the power 5 plus x cubed y square minus x square y cube x square y cube minus y to the power 5 is equals to c. This is the answer for the given exact differential equation, right? Now let's take one more example for the exact differential equation. So first thing is to check exactness of any given equation. Let's talk about this equation, that is 2xy cosine x squared minus 2xy plus 1 dx plus sine x squared minus x squared plus 3 dy. So the first step is to identify m and n. That is pretty simple. Whatever is with dx, we'll call it as m. So here m is 2xy cos x squared minus 2xy plus 1. And whatever is in the product of dy, that will be simply this one part is n plus 3. Right, so let's apply the partial. So here it will be with respect to y, so it will equal 2x cos x squared minus 2y, and then for dou n over dou x, for sine x squared it will be 2 times, sorry, it's sine x squared, which means it will be cosine x squared into the derivative of angle, that is 2x, minus, then we have x squared here. Here I did mistake, it's 2xy, so with respect to y we are differentiating, we left with 2x. So here we'll also, the derivative of x squared will be negative 2x. So we can see here that this is dawa m is equals dawa m over dawa y is equals to dawa n over dawa x, which is equals to 2x cosine x squared minus 2x. Now, what we need to do, the equation is exact, so we just need to integrate the given parts, that is 2xy cosine x squared minus 2xy plus 1 dx, and then plus sine x squared minus x squared plus 3 times dy is equals to 0. Now here y is constant, and again here any function of x that is given will be 0. So this will be 0, this will be 0, right? X is here. So we'll integrate this, so we'll get with respect to x. Now we are going to integrate this with respect to x. So y, we can take 2y outside and it will be x cos x squared, and then for this one dx, and then for minus 2y again here, and we can integrate x dx, then plus 1 dx, and then plus 3 dy is equals to 0. Now we can integrate this using by path rule, so it will be 2y into x sine x squared over 2x, and or we can just simply uh, use the assumption that will be pretty easier for us. Let u is equals to x squared, so du over 2 will be equals to x dx, therefore we can replace here x dx, so it will be 2y times cos u du over 2, which means 2 will cancel out and we will left with y sine u, which means this is equals to y sine x squared. So we can just write y sine x squared in place of this function. So the integral of this one will be y sine x squared minus 2y x squared over 2 plus x plus 3y is equals to c. That is the constant of integration, so it will be y sine x squared minus x squared y plus x plus 3y is equals to c, not 0, this is c. All right, so this is the idea of the exact equations, solving exact equations. Let's take one more example, uh, probably the last example of this lesson, and then you can practice these problems from books. So it's 1 plus e to the power x over y, and plus we have e to the power x over y times 1 minus x over y times dy over dx. First of all, make this equation in the form, we can write it as e to the power x over y dx plus e to the power x over y into 1 minus x over y dy is equals to 0. So identify m and n. So here is m, 1 plus e to the power x over y, and n is equals to e to the power x over y. 1 minus x over y. Right, so find our m over our y. This will be 0 plus this will be e to the power x over y times the derivative of x over y, which means it will be negative x over uh, y squared. Negative x over y squared, right? I think so. It's yes, fine. So it will be negative x over y squared e to the power x over y. Now find dawa n over dawa x. All right. So in this case, what will be dawa n over dawa x? Just need to differentiate this function, that is n. So we'll apply the derivative. So with respect to x, it will be x over y dot 1 over y, then minus or first let me write it here. No need to confuse. We can write in this way. Right, x over y. Now differentiate this function. So for this, the derivative will be e to the power x over y times 1 over y minus, then for this one we have x over y dot 1 over y, and then minus with respect to x we are differentiating, and so this will be x over y times e to the power x over y times 1 over y. So this cancelled out and we are left with negative x over y squared e to the power x over y. That is dawa n over dawa x. Now let's check what was dawa m over dawa y. That was also equals to the same function. You can check here. Here we can see that here. I will box it with red. So it is same as dawa n, this one. So we can see that this equation is exact equation. So now we can solve it by simple integration here. So it will be 1 plus e to the power x over y times dx plus e to the power x over y times 1 minus x over y dy is equals to 0. So here we can see that this is the function of x and y, where x is also involved and is multiplied by the whole function. So this whole function will be 0, right? So this whole integral is 0. We don't need to integrate this function. So put y is equals to constant and simply integrate this function. We will get x plus e to the power x over y over 1 over y is equals to c, which means that the solution is x plus y e to the power x over y is equals to c. That is the answer, right? So we saw in this lesson that how to identify the exact equations, how to proceed the solution of exact equations, and before diving into the problem you just need to check whether the equation is exact or not, right? So in the next lesson we will see that how we can make some equations that are not actually exact, but we can make them exact by using some multiplications and divisions, right? So we will see in the next lesson. That's all for the time being. Thanks for watching the lesson. Goodbye.